Hello YouTube, today we're going to be looking at a circuit involving different voltages and current source magnitudes. So you have the same circuit but just using different values for the battery and the current source. So we're going to take a look at how to solve this problem systematically. So here is the part A. So if you have the battery that's 10 volts and the current source of 0, what would the circuit look like based off of this original circuit we see here? Well, let's start with the battery. So we just plug in the battery to equal 10, everything else is the same. But I1 equals 0, the current source is 0, what does that tell us about the circuit? Well, that we can completely ignore it, because at that point there where I is equal to 0, there is no current passing through, therefore we can completely ignore that left half of the circuit, including that 5 ohm resistor. So now our new problem is just the circuit here, that right half of the circuit, which notice how the two resistors are in series, so we sum them together to get 10 ohms, and then we simply use Ohm's law, I equals V over R, and calculate the current through that part of the circuit, and that is 1 amp. To calculate the voltage across that resistor, we take the total current multiplied by the resistor that the current is flowing through. In this case, it's a 5 ohm resistor across V3, so we get 1 times 5, which is 5 volts. However, based off what we assigned the V3 to be positive and negative in red, actually the sign is flipped. If you notice, because current flows from high to low potential, so that's like positive to negative, and if you follow the loop of the battery, you come from the positive end, you go through the left resistor, and then you come up from the bottom there. So actually positive, it'll be positive when the current flows through there and leaves negative. So that's why we know the sign is negative, and therefore we have V3 is negative 5 volts. Now let's set up another scenario. Part B asks, 1 volt, or the battery of V1 is 0, so there's no battery pretty much, and the current source is now 10. So let's look at that. This is part B. So with the battery being 0, pretty much is just saying now there's just a wire there. That's all it means. And then I1 equal to 10, we just plug in 10 amps there, and we solve for V3. Now you may be wondering, why did I put that resistor in purple? Why did I cross that out? Well, there's a really cool trick actually. We can ignore that resistor since we know that the current from the current source is already going to be 10 amps. So it doesn't even matter what that resistor is because we know the current's going to be 10 amps anyway. So we can reduce the circuit down by showing that 5 ohms are in parallel with 5 ohms, and then we get 2.5, and the way you can kind of shortcut it is 5 parallel with 5 is just half, so then you get 2.5. So that's how we know what Req is, and we got our simple circuit here, so we use Ohm's law, V3 equals IR. We know the current source is 10, R is 2.5, and V3 is therefore 25 volts. And we were able to do this because this circuit here was in parallel. Cool. Next, part C says the V1 is 10 and I1 is 10. What's V3? Well, we plug those in there. Wait a minute. Take a look. Part A was this one, where V1 was 10. Part 2, we got negative 5 volts. And part 2, or part B, I1 was 10. And we got 25 volts. Well, now we have both of them. V1 is 10, I1 is 10 at the same time. So rather than doing a bunch of math again, or setting up an equation, notice that these are the same problems A and B, just asked at the same time. So this is a superposition problem. So by superposition, we can just sum the voltages. So 25 volts was from what we got from the 10 amp current, right? And then we had negative 5 volts from the 10 volt battery. So by combining the answers we got in V3 from part A and B, we can say V3 for part C is 20 volts. So that's a really cool shortcut, especially if you're taking an exam. This was a practice exam, so figured it would be good to go over a quick trick instead of doing the problem over again. See if you can figure this one out. V1 is equal to 5 volts, I1 is equal to 5 amps. So it's the same setup here except half of that. Oh, well, okay. So just half of 20, which is what we got here. So 20 divided by 2, because it's exactly half of problem C, which had 10 volts and 10 amps instead of 5 volts and 5 amps. So that means the voltage drop, or the voltage is 10 volts. Boom. So there's how you do that problem. Pay attention to those shortcuts for, they might be very similar things based on problems you've already solved that can help you out in getting your answer for a problem later on. So hope that helped. It was a good test taking strategy for you, and keep studying.